Alright, so I think I'm recording now. I want to do some selected solutions of some of our previous homeworks. See if this helps people. So let's, from this skill packet number 7, let's take a look at some of these. So this is what the top of the worksheet looked like. And let's just do like problem 1. We'll jump around. When you first learn about square roots, when you first learn about multiplication, you could recall that if you have a positive number times a positive number, you'll get a positive number. If you have a negative number times a negative number, you'll get a positive number. If you have 0 times 0, you'll get 0. So the idea of a square root, if they're asking us what is the principal square root of 4, they're asking us, is there a number times itself that equals 4? So we've been breaking it down and saying, yeah, I have a pair of 4s, or excuse me, a pair of 2s. So the square root of 4 is equal to 2. And we can do it with larger values and stuff as well. We can use a calculator to help us if we need to. But if we take a look at a problem like this number 1, we run into a little bit of difficulty, because a number times itself, if I have negative 36 and I'm trying to think of a number times itself that equals negative 36, well, 6 times 6 doesn't work because that would equal positive 36. So I can't try that. A number times itself, a negative 6 times a negative 6, well, that's a positive 36 and that doesn't work. So in the set of real numbers, a number doesn't exist like this. So around 1700s or something like that, there was a German mathematician by the name of Karl Gauss, and he looked at solutions to equations of what they call polynomials, and specifically wanted to come up with the solution to this equation, x squared equals negative 1, and from there he expanded the set of real numbers to be a larger set of numbers, the complex numbers, and he defined a new number, I, and that I was defined to be the square root of negative 1. So when you take I times I, or you take the square root of negative 1 times the, by definition, I should write that I squared, that I squared is equal to negative 1. So these are two primary ideas that we really need to have memorized. Now, we saw in our notes that we should really memorize a little bit more than that, and that's the powers of I. If you have an even power, it's going to either be negative 1 or positive 1. If you have an odd power, like 1 or 3, it's either going to be I or negative I. If you have numbers that are exponents that are larger than 5, we've seen that we can use a calculator, divide by 4, look at the decimal point, the remainder, and reduce it to one of these 4 values. So you want to have that memorized. You want to know that. Alright, so how am I going to do this problem? Let's just jump in and do it. The negative 36, I'm going to look at that as the square root of negative 1 times the square root of positive 36, and I'm going to have 6 times 6. Hey, that's 36. By definition, the square root of negative 1 is I, and when I multiply it by the radical 36, well, I just get 6, and we typically write it with 6 times I. So there's my final answer. If somebody asks me, hey, what's the square root of negative 36, I'm going to tell them 6i. All right. So it's easy to see here that the square root of negative 121 is going to be 11i, but then you're going to take the opposite of it, and it's going to be negative 11i. Let's take a look at number 3. It's kind of interesting because it's symbols, that people don't see all that often, the plus or minus. I guess you see it a lot with the quadratic formula, but so this is just shorthand notation for two numbers. The first number is the positive square root of negative 49, and the second number is the opposite of that, is the negative square root of negative 49. So I'm going to have two answers. Over here I'm going to break down negative 49. I'm going to have the square root of negative 1 times the square root of positive 49. I'm going to break 49 down to 7 times 7. By definition, the square root of negative 1 is I. The square root of 49 is 7. And we typically write that as 7 times I. So over here, I have the opposite. Well, now I break the square root of negative 49 down to the square root of negative 1 times the square root of 49. I break the 49 to 7 times 7. Don't lose that negative sign. By definition, the square root of negative 1 is I, and the square root of 49, we've just shown that it's 7, and you'll likely see that as negative 7i. So, since these are our two solutions, you often see people use shorthand notation to express those two solutions like they did at the beginning. So you might see people write that plus or minus the square root, here let's write it out, that plus or minus the square root of negative 49, well, here's positive, here's negative, so we could write plus or minus 7i. And there's our final answer for problem 3. So let's see what looks interesting. Well, let's take a look at number 6. Up until number 6, the radicals have been perfect squares. We know that the square root of negative 54 is not going to be a real number. It's going to be a complex number. The negative sign, I can break this apart to the square root of negative 1 times the square root of 54. And I'm going to have to pause this real quick. Sorry about that. 54 is 9 times 6, and 9 is a pair of 3s. We're looking, when you have a square root, for groups of 2. Alright, so by definition, the square root of negative 1 is I. Because we have a group of 2, we can write a 3 outside of this. So this is times 3, but what's still underneath there, the 6 broke down to 2 times 3. We don't have a pair in there, so this stays the square root of 6. And you might see this written in a variety of different ways. I usually write it 3i times the square root of 6, because in textbooks they'll write they'll write 3 times the square root of 6 times I. But if I'm handwriting it, I don't want somebody to think that my radical extends over that I. So you'll see me either, if I do write it like that, I'll put a little hook on the bottom of it to show that, hey, it stops there, that I is not underneath there. But because of sloppy handwriting, what I normally write is the 3i in front times the square root of 6. That way nobody mistakes I for being underneath the radical. Alright. So let's jump down here to number 9. The square root of negative 8i is the square root of negative 1 times the square root of 8 times the square root of negative 1 times the square root of 12. By definition, the square root of negative 1 is I. And I can multiply in any order, so I have another I. And when I multiply I times I, we write that as I squared. Now, the square root of 8 times the square root of 12, 96. I times I is I squared. And let's break down 96. Is that 16 times 6? It's kind of late and I'm not thinking very well. Yeah. If I break this down to 16 times 6, I can easily break down 16 into a group of 4s. Now if you broke it all the way down, you would have a group of 2s and then another group of 2s. So I'm going to write I times I is I squared. I found a group of 2, so I'm going to write that as 4 on the outside of the radical. What still remains underneath the radical, the 6, it broke down to 2 times 3, which I didn't get a pair of numbers there, so it just stays the square root of 6. Now remember, we have these powers of I. We need to have it memorized that I to the first power is I, that I squared is negative 1, that I cubed is negative I, and that I to the fourth power is equal to 1. So here I have I squared, so my final answer, negative 4 times the square root of 3. So if someone had asked me, hey, can you multiply the square root of negative 8 times the square root of negative 12 for me, I'd say, yeah, sure. I get negative 4 times the square root of 6. So there's my final answer for problem number 9. Let's take a look at this division problem in number 12. If it were me, I would rewrite this as the product of two square roots, 9 over 25. Well, that's a positive value. This is negative. I'm going to have to multiply it by negative 1. So I know that the square root of negative 1 by definition is I. And I also know that if I take the square root of a fraction, I can take the square of the numerator and the square of the denominator separately. I can break 9 down to 3 times 3. I can break 25 down to 5 times 5. And when I'm doing square roots, I'm looking for a group of 2. So in the numerator, this 9 is 3 squared, so hey, the square root of 9 is 3. And in the denominator, the 25 is 5 times 5, so the square root of 25 is 5. And then I'll typically write that 3/5 out in front of the I. So that's my final answer. If I have the square root of negative 9 over 25, I claim that that simplifies to 3/5 times I. Alright, so let's illustrate how these ones here at the bottom are just a calculator exercise. Let's use our calculator to do a few of these. I raised to 213. So I need to have it memorized these powers of I. Now I also want to have it memorized that length is 4, so I'm going to take this exponent 213 and I'm going to divide it by 4. Now every time you divide by 4, you're going to have a remainder that's either 0, 1, 2, or 3. You'll never have a remainder of 4 because then the divisor would just go back into it one more time. So your remainder is always smaller than the number you're dividing by. If I'm dividing by 4, my remainder always has to be smaller than 4. Well, on a calculator, I'm going to take 213, which I think it was 213, yeah, and divide it by 4. Now, before I hit enter, I know that one of 4 things is going to happen. The decimal point, the remainder, is either going to be, see, let's fix this to 2 decimal places. So my decimal number, yeah, there'll be a number in front, but the decimal part is either going to be 0.00, 0.75, 0.50, or 0.25. There's not going to be any other possibility when we divide by 4. So let's see what we get. 0.25. So I know that since the remainder was 0.25, that I raised to the 213th power reduces to just I. Now I also knew that from my 4 powers here, that since that exponent was odd, I knew it was either going to be I or negative I, because 1 and 3 are odd. Had that been an even number, like 2 and 4 there, it would either have been negative 1 or positive 1. But that's my final answer for number 17. So let's go and pick another one. Here, let's pick this number 18. Let's figure out that negative sign. I'm just going to leave it alone. And I'm going to take 21, divide it by 4, and look at my remainder, 0.25. So when my remainder is 0.25, when you divide by 4, and if you have a remainder of 1, 1/4 is 0.25, then this is going to I to the 21st power. Since it's odd, it's either going to be I or negative I, and since that's 0.25, it's I. See the 0.25, see the I. So don't forget that negative sign out in front though, because it's wanting us to calculate the opposite of I to the 21st power. And the opposite of I is negative I. So there's my answer for number 18. Oh, let's take a look at the very last one, 21 there. My exponent's an even number, so I know to expect my answer to be 1 or negative 1, not I or negative I. That would have happened if it was an odd number. I go to the calculator. Well, I know this is going to be I raised to some power. I go to the calculator and I take 382 and I divide it by 4. And I get 0.5, which means that this guy is I squared, and I know by definition that I squared is equal to negative 1. So there's my final answer, that this I raised to the 382 powers reduces to negative 1. Alright, let's take a look. I think that's it for the, yeah. So if you need more solutions for this, go ahead and ask me, but I think that will help you with the rest of these problems on 7A. Hope that helps.